Hello everyone. Let us start solving another one video numerical problem based on finding electric field intensity due to point charge and line charge. Here in this question, you are asked to find electric field intensity at point P with coordinates 1, 5, 2 in free space due to a point charge and a uniform line charge. The point charge magnitude is 6 microcoulomb and it is located at the coordinates 0, 0, 1. And a uniform line charge has charge density of 180 nanocoulomb per meter is along x-axis, which means the entire x-axis is infinite in length. This line charge is an infinite line charge. Let us start solving the numerical problem taking graphical representation for the location of both point charge and line charge. So I will consider the reference XYZ coordinate system, and in the XYZ coordinate system, we can fix where the line charges and the point charges and the point where we have to find electric field intensity as well. So let us consider the line charge is along entire x-axis. So this is where the line charge is present, which is having charge density value of 180 nanocoulomb per meter. And there is a point charge which is at 0, 0, 1, where x coordinate is 0, y coordinate is 0, and z coordinate is 1 lying along z axis. So this is the point where charge Q of 6 microcoulomb is present and a line charge of 180 nanocoulomb per meter is present. We are supposed to find electric field intensity at a point P whose coordinates are 1, 5, and 2. This is the point where we are finding the electric field intensity. This electric field intensity will be due to both point charge and also the line charge. So we should find the electric field intensity due to point charge separately and electric field intensity due to line charge separately to get the total electric field intensity at the point P. Let me write the notation for total electric field intensity as summation of electric field due to point charge plus electric field due to line charge. Here I have indicated the subscript P indicating it is due to point charge and subscript L indicating it is due to line charge. Let us write the formula for electric field intensity due to point charge. I'll write this is electric field due to point charge. Now this is given by Q by 4 pi epsilon, and here it is free space, so epsilon becomes epsilon naught vector r divided by magnitude of r cube. Now this vector r is from charge Q to the point P. So this is the vector r. To indicate this is for point charge, I am giving subscript P also. Here I am indicating RP, which is electric field due to point charge. We can find RP vector. The RP vector will be equal to coordinates of P minus Q. So let me write 1 minus 0 in x direction, then 5 minus 0 in y direction, plus 2 minus 1 in z direction. This gives R due to point charge as AX cap plus 5AY cap plus AZ cap. We can find magnitude of this RP vector. Magnitude of RP vector is under root 1 square plus 5 square plus 1 square, which is under root 25, 26, 27, root 27. Or we can find the value in the calculator also. So under root 1 square plus 5 square plus 1 square gives 3 root 3 or 5.196. I'll write this is 5.196, which is magnitude of RP vector. We can make the substitutions to get the electric field due to point charge, and we can find electric field due to line charge as well. So I will write electric field due to point charge expression is charge Q which is 2 microcoulomb. Sorry, 6 microcoulomb, which is 6 into 10 power minus 6, and 1 by 4 pi epsilon naught. We know the value of 1 by 4 pi epsilon naught is 9 into 10 power 9. We can write 9 into 10 power 9 in the numerator, and vector Rp is Ax cap plus 5Ay cap plus Az cap divided by 5.196 the whole cube. I should compute this and find E vector. So let me take the calculator and we can compute this value also. So it is 6 into 10 power minus 6, 6 micro, and 9 into 10 power 9 divided by 5.196 cube. This has to be multiplied with 1, 5, and 1. So let me first compute what is the value with 1, which is 384.93 Ax cap. So I'll write 384.93 Ax cap, and same one is there with Az cap also. So 384.93 Az cap, and we should find what is Ay component. So this has to be multiplied with 5. So 1924.67. 1924.67 Az cap. So electric field due to point charge is 384.93 Ax, then 1924.67 Ay plus 384.93 Az. We should not forget to indicate the unit of electric field intensity, which is volt per meter. This is due to point charge. Next, we can do the computation of electric field due to line charge also. So let me consider a line charge along x-axis, and the point at which we are finding electric field intensity is 152. Let me confirm again, 152. So this is where we are finding electric field due to line charge separately now. To find this, we know x-axis extends from minus infinity to infinity, and the equation of x-axis should be given where what is the value of y and z we should mention. So when you look at the x-axis in xyz coordinate system, throughout x-axis, x value changes from minus infinity to plus infinity. Y value is 0 and z value is 0. So we have to consider value of y and z as 0 at any point on x-axis. So we have to write any point on x-axis can be represented as x comma 0 comma 0, where x takes the value, any value from minus infinity to plus infinity. This is required when we have to find vector r. So let me go to how to find vector r due to electric field produced by line charge. Before that, I'll write the formula for electric field due to line charge. Especially here, it is infinite line charge. We have a separate formula for finite length of charge. This problem talks about infinite length of charge. So I'll write the expression for electric field due to infinite line charge. Since it is line charge, I'm giving subscript L. The formula is rho L by 2 pi epsilon rho a rho cap. And here the medium is free space. We should write epsilon as epsilon naught. And one more thing, this rho L is the charge density, but this rho and a rho cap has to be found from R vector. From R vector due to line charge, or we can write RL vector. This can be found from RL vector. To find RL vector, we have to draw perpendicular from point P to the line charge. After drawing perpendicular from point P to the line charge, we can find intersection of point P dashed along the line charge. We should find what are these coordinates to get vector RL. To find vector RL, RL vector is from the line charge to the point P. So this is RL vector. To find this RL vector, we need the coordinates of P dashed, where we have drawn perpendicular from P to P dashed through to the line charge. So we know this is along x-axis. Any point on x-axis can be represented as x0, 0. So we should mention the coordinate of y and z as 0. Whereas for x coordinate, the x coordinate will be same as for the point P. So we can write the x coordinate as here 1, because we have drawn perpendicular from point P. So the coordinate of x is same between point P and this intersection point. So whatever is the coordinate of point P for x, the same should be for P dashed for x also. Now we have P dashed coordinate and P coordinate. We can find the R vector for line charge. Let me write RL vector, which is directed from P to P. So P coordinate minus P dashed coordinate we should write. So let me write, which is 1 minus 1 in x direction, plus 5 minus 0 in y direction, plus 2 minus 0 in z direction. So we have 5 ay cap plus 2 az cap. This is for RL vector. We have to find magnitude of RL vector and direction of RL vector. So I have already mentioned this A rho, cap and rho can be found from RL vector. I'll give the formula also. A rho cap is RL vector divided by magnitude of RL vector, and rho is just the magnitude of RL vector. This should be remembered when we are solving line charge problems. So by substituting these A rho cap and rho cap, rho, so we can have EL vector as rho L by 2 pi epsilon naught, magnitude of RL in place of rho, and A rho cap can be written as RL vector divided by magnitude of RL vector. So these two product I can write as square in the denominator. I can write as square in the denominator. Now, when we know or we compute the RL vector, we can find electric field due to line charge as rho L by 2 pi epsilon into RL vector divided by magnitude of RL vector. We should now estimate what is magnitude of RL vector, which is under root 5 square plus 2 square, which is under root 29. We can get the value from the calculator as well. Under root 5 square plus 2 square, which is under root 29, which is equal to 5.385. So this is magnitude of RL. We can now substitute RL and magnitude of RL, also rho L value, to find electric field intensity due to line charge. So we can estimate 180 nano coulomb per meter is rho L, and we should write what is 1 by 2 pi epsilon naught value, and RL vector, which is 5 ay cap plus 2 az cap divided by 5.385 the whole square. Now we can write 1 by 4 pi epsilon naught as 9 into 10 power 9, which is the constant from Coulomb's law. If I want 1 by 2 pi epsilon naught, this has to be multiplied with 2, which gives 1 by 2 pi epsilon naught, which is nothing but 18 into 10 power 9. So I can replace 1 by 2 pi epsilon naught as directly 18 into 10 power 9 in the numerator. This should come in the numerator. We can compute this to find electric field due to line charge. Let me do the computation. 180 into 10 power minus 9 into 18 into 10 power plus 9 divided by 5.385 square. So this should be 5.385 the whole square. So this has to be multiplied with 5 and 2 correspondingly to get the y component and z component. So for y component, it becomes 223.461. 223.461 ay cap. And for finding z component, this has to be multiplied with, this has to be multiplied with 5 for y component, which is 558.654. So this is 558.654. And then for finding z component, it should be multiplied with 2, which is 223.461. 223.461 in z direction, which is electric field due to line charge. Now we should add up the electric field intensities due to point charge and line charge to get the total electric field intensity, which is the requirement of the problem. So we have to add electric field vectors which we have obtained for line charge and point charge to get total electric field intensity. So here, when you look at AX component is only available here. For AY component, this has to be added with this AY component. And for AZ component, this has to be added with this AZ component to get the total electric field intensity vector. Now, adding the two, we can get the total electric field intensity. I can do that in calculator and let us try to get the answer. So for Y component, we should add 558.654 with 1924.67. That is 2483.324. 2483.324. And for Z component, we should add 223.461 with 384.93. That is 608.391. 608.391 in Z direction. X component has only one term, which is 384.93 AX cap. This is the total electric field intensity. We should not forget to mention the unit, which is volt per meter. So this is the final answer for electric field intensity, which is given by both point charge and also line charge. If you have any doubts about how to solve this point charge and line charge problem, you can rewatch the video and try to understand. This similar concepts will be required for solving point charge and infinite line charge problems. Thank you for watching.